Alright, last example for trig equations. We're going to do one a little bit different. This one has just a single trig function in it, but it's not factorable as a polynomial. Right? So tangent squared plus 4 times the tangent theta plus 2 is equal to 0. Well, we have the 0 on one side. It is kind of a polynomial style of equation. And so it would be similar to the equation, say, x squared plus 4x plus 2 equals 0, if you had a similar type of equation using x instead of tangent of theta. And so what I'm going to do is go ahead and solve the polynomial version, and then I'll replace the x at the end with the tangent, because that's really what we're looking at. So how would I solve this? Well, generally speaking, you would try factoring. Unfortunately, factors of 2 that add up to 4 don't exist, right? 2 is 1 times 2. There's no other factors that are integers, and so 1 times 2, 1 plus 2 doesn't add up to 4, it adds up to 3, so it doesn't factor. So we have to use the quadratic formula, everybody's favorite. So the quadratic formula, of course, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so now we've got to plug everything into that. I'm going to go ahead and do that over, starting on the left, and run it across the board. Now, of course, the a value is 1, because that's our lead coefficient. The b value is 4, that's our middle term. And the c value, our constant, is 2. Alright, so we plug those three values into the quadratic formula. And so x is equal to negative 4 plus or minus the square root. Now 4 squared, I'll just jump right to that, is 16. Minus, well, 4ac. 4 times 1 times 2 is 8. So we'll jump right to the 8. All over 2a. Well, a is 1. 2 times 1 is 2. So we'll pop that in the bottom. And then we do some simplifying, right? So this becomes negative 4 plus or minus the square root of 8, 16 minus 8, all over 2. And of course, if I simplify this a little bit more, the square root of 8 is 2 root 2. So this becomes negative 4 plus or minus 2 root 2 all over 2. And then I could split that 2 to each term on top, right? 4 divided by 2 is 2. 2 root 2 over 2 is just root 2. Lots of 2's. Maybe I'll write it this way. I'll write it out a little bit. So x is negative 4 over 2 plus or minus 2 root 2 over 2. So I split that denominator up to both terms. 2's cancel there. 4 over 2 is 2, so this becomes negative 2 plus or minus square root of 2. Okay? Okay, so now this is what I solved for x. But remember, we don't have x in our equation, we have the tangent of theta. So technically, it's the tangent of theta that is equal to negative 2 plus or minus root 2. Okay. And so what I want to do is find all values of theta which have a tangent value of negative 2 plus or minus root 2. Okay, well there's two different values there, one with a plus, one with a minus. I need both. A couple different approaches to this. One of them, the one I'm going to take, is to approximate this with a decimal, the negative 2 plus minus root 2, only to determine which quadrants we're looking at. Then we're going to go back and use the exact form to evaluate the tangent. Okay, so I'll go to the calculator real quick, and I'm going to need a little, well, I'm going to use a different color just to separate this off. So negative 2 plus the square root of 2, we'll take them one at a time. negative 2 plus the square root of 2 is right there. And negative 2 minus the square root of 2, I'll do them separate. Could have done them both and then showed you. There it is. Okay, so those are my two values. They're both negative, interestingly enough. So the one with the plus, the one with the minus. The one with the plus is going to be negative 0.586. I'll round that off, and this one is negative 3.414. We'll round them to the nearest thousandth. It's kind of been our theme here. That may not always be the case, but now again, I'm not going to use those rounded decimals because I don't want to round. Rounding creates error, and error is bad, generally speaking. So I want to keep things in as exact a form as possible. The only reason I did that was so that I could determine what quadrant or quadrants theta is in. Now using the plus, we still get a negative. In fact, whether we use the plus or the minus, we still get negative answers there. So that means that theta must be in the second and fourth quadrants. Remember, for the tangent, ASTC, that's a bad C, tangent is positive in the first and third, negative in the second and fourth. So we need second and fourth quadrant angles for both of those answers. Okay, so keep that in mind. Your inverse tangent button on your calculator is only going to give you a first quadrant angle or a fourth quadrant angle, and the fourth quadrant angle will be negative, which we don't want, right? We don't want a negative answer here. So we're going to have to do quite a bit of adjusting at the end of this. Okay, so I know then that theta must equal a couple different things. It's going to be the inverse tangent of negative 2 plus root 2, or it could be the inverse tangent of negative 2 minus root 2. Okay, so we're going to have those two expressions. They're equivalent to this, and I'm taking them one at a time. Again, in each of these, you're going to get two angles, one in the, when I say second quadrant, and one in the fourth quadrant. Okay, when I punch this into my calculator, and again remember, I don't want to use the rounded decimals. When I punch this into the calculator, I want inverse tangent of negative 2 plus square root 2. Oh, but I also want to be in degree mode, which I'm not, because I've got degrees up here, right? So, inverse tangent, negative 2 plus square root 2, negative 30.4 roughly. Now what quadrant is that in? Well, it's the fourth quadrant, right? It's a negative angle between 0 and 90, right? Or 0 and negative 90. So it's a fourth quadrant angle. So that tells me negative 30, what did I say, 0.4? That's an approximate. Okay, so now what I have to do is convert that to an angle in my interval from 0 to 360. Well, if I just add 360 to that, that would loop it from the fourth quadrant angle all the way back around to another fourth quadrant angle. So I'm going to add 360. Very simple. Just hit plus 360, and you get 329.6, right? So one of the answers I'm going to need, and maybe I'll just start building my solution set right now. I'm just throwing stuff in there as we go. 329.6. Okay, that's the first one. That's a fourth quadrant angle. I also need a second quadrant angle, okay, to get the, yeah, let me draw this out so it can be a little more clearly explained how these quadrants work out. All right. So this angle is going to be the negative 30.4. Then that's equivalent to this 329.6, okay, if you go around the other way. So what I want is a similar angle in the second quadrant. Yeah, looks kind of cruddy. Alright. I have a hard time drawing straight. Anyway, there it is. Wow, that's really crooked. Oh, it's even worse. Oh my goodness. I should edit the video, but I'm going to let you guys laugh at me as I do this. There, that's not terrible, maybe. Anyway, oh man. So we want to do 180 minus the 30.4. Okay, so that would be you go over 180 and then back to 30, another 30.4. So, and right now I'm rounding everything to the nearest tenth anyway, so I'm not going to worry about rounding. I'll go ahead and round as we go. So it's 149.6. Okay, so that will be my second angle, is 149.6. Alright, so that's my second quadrant angle. So I've got a fourth quadrant angle and a second quadrant angle corresponding to this first value with the sum. Now I want the ones with a minus. Well, I'm going to go to my calculator again, and I type in inverse tangent of negative 2 minus square root 2. Alright, and that gives me negative 73.7, roughly. Okay. Now again, remember this is a fourth quadrant angle, which we want, but it is it's not in our interval because it's negative. So I need to add 360 to it again. So I just hit plus 360, and I get 286.3. Oops. Okay, so 286.3. Let's move that. Put down there. Okay, and that angle in the fourth quadrant would be something down there, I suppose, right? So it's about 73.27 negative. Okay. So now what we want is a similar angle or corresponding angle up in the second quadrant. And so to do that, you would go around to 180 and then subtract off the 73.7 again. So 180 minus 73.7. And that'd be 106.3. That would give me the fourth angle, the second angle for the second value from the quadratic formula. Okay, so in theory that should work. These four angles should, if I plug them in for theta up here, make the left side of the equation equal to 0. Maybe I'll show you that or verify it for just one of these. Let's go with the 149. I'll just pick one. 149.6 degree angles. Just as a quick check, make sure I didn't do something crazy here. I'm going to type in tangent. Oh. Now when you do a square on a trig function, surround the whole thing with a parenthesis. Hit parenthesis, tangent, plug in the, I'll do 149.6, and then put another parenthesis and square that. Okay? So it would look something like that. That's the first term. Then you would add to that a 4 tangent, same thing, 149.6. You always have to take the same angle and put it in both spots. And then add a 2. And, interesting. I don't get 0. but I get something close to 0. And the reason I don't get 0 is because I rounded. If I didn't round, I would have gotten 0 there. Okay, so it's pretty close. Could try it again, but if I had left more decimal places there on that 0.6 and not rounded that off, we'd have been much closer to 0. So hence the error. Anyway, it works out if you were to do that with more precision than I am. Okay, and you could try that with the other 3 angles. You'll get something very close to 0 again, and the difference would be due to the rounding error. Okay. Again, you always want to round at the end. You don't want to round anywhere in the middle of the problem and then have that rounding error compound as you do other operations with the number. In our case, I rounded it off once, and then I used that number only in an addition or subtraction where I was going to round to the same place anyway, so it didn't really add to the error. But even that one rounding did create quite a bit of error, as you can see. Okay. But anyway, so you got 4 answers using the quadratic formula, and really just analyzing 2 different quadrants on this one.